Hello, my name is Kevin Mickey, and I am the director of the Professional Education Program, which is located at the Polis Center at Indiana University, Purdue University, Indianapolis. The seminar that you are about to view, HAZUS MH for Decision Makers, represents a joint collaboration between the Federal Emergency Management Agency and DSRI. I want to welcome you to this seminar, and I hope that you are able to benefit from your experience during this next hour as we begin to explore this important technology. During the seminar, we're first going to start out with a review of what HAZUS MH is, how it can help us address the issues related to hazards, and what kind of information that it will produce. We're then going to look at some examples of applications of HAZUS to the study of hurricanes, floods, and earthquakes, and then we'll end with a wrap-up of information about how you can obtain HAZUS, how you can obtain training for this application, and where you can find other users that are applying the technology within their own areas. Let's start out with a discussion of HAZUS MH and what it actually is. HAZUS allows us to provide what is called a risk-based approach to disaster management. What that means is that we can look at a geographic area and we can assess, based upon information about hazards that have occurred in that area or that might occur, whether a risk exists and what that risk might be. With that information, we can calculate scientifically defensible estimates of damages, economic losses that might occur as a result of those damages, and the impacts of various types of mitigation that we could place within our areas. HAZUS resides on a geographic information system. What this means is it allows us to not only assess whether a hazard exists, but it also allows us to visually display where that hazard is and the vulnerabilities, such as the buildings in our community, the people that live in the community, and how the hazard and that exposure interact. One of the really wonderful things about this technology is that it is absolutely free, and it's an extension of ArcGIS 9, which means that not only do you have all of the tools that HAZUS provides, but you have everything that ArcGIS comes with as well, which opens a tremendous wealth of possibilities for assessing, analyzing, and determining how to address hazards within your communities. Once you install HAZUS, you immediately have access to well over 200 publicly available layers of information. That information can be broken down into two categories. One category is what we consider common to all hazards. For example, the types of buildings that might be found in your community, such as residential buildings, commercial buildings, industrial, and others, and information about how those buildings are constructed, such as are they made from wood, steel, concrete, or other materials. Other information that's common includes things like lifelines, such as bridges, the cost to replace structures in our other inventory, and information about the people that live in the areas that we want to study. The other type of inventory information is what we term hazard-specific inventory, and this addresses issues that are important to specific types of hazards, such as earthquakes, where we need to understand detailed information about how a building is engineered, and information such as environmental data, which is relevant if we want to, for example, study the impact of flooding on our community. And examples of environmental data include things like rainfall, elevation, soils, and many other types of things. A very important question that we really need to consider is, why do we need a tool like HAZUS MH? On this slide, you see a list of some of the more well-known disasters that have occurred during the past few years, but we all need to understand that disasters do not just happen periodically. They are something that affect us on an ongoing basis. Consider these facts. On an average, 70 to 75 damaging earthquakes occur around the planet, and it's been estimated that losses from a future U.S. earthquake could approach $200 billion. Another issue is that earthquakes, as an example of a hazard, occur in nearly every state of this country, and 45 of those states are at risk from moderate to very high risk of earthquake events. Consider other hazards such as hurricanes. On an average, 5 hurricanes strike the U.S. coastline each year, and 2 of those 5 hurricanes are typically major hurricanes. Between 1972 and 2001, also consider that flooding is a major issue. On average, 127 people during that period were killed by flood-related events, and between 1992 and 2001, floods actually cost this nation more than $4.1 billion on an annual basis. So we've established that disasters are a major concern, and we need a way to address those, and that leads us to HAZUS MH. What HAZUS will allow us to do is first to identify where we are vulnerable to disasters. Remember that HAZUS resides on a geographic information system. This means that we can see geographically where disaster risks might occur. With that information, we can also assess how ready we are to deal with a disaster before that disaster actually takes place. And then we can estimate what the losses might be from various types of disasters. Very, very important information for a planner to know so that they can effectively make plans to address those needs and decide on how to allocate the resources that they have in order to respond and recover from that disaster event. With that information, we're able to prioritize various mitigation measures that we can take and determine how those can be implemented in order to reduce the further losses or future losses that we might see from a disaster. HAZUS currently supports 3 types of hazard analysis, those being hurricane events, riverine and coastal floods, and earthquakes. We're going to explore each of these types of hazards and the type of information that HAZUS will provide during this session. When we look at how HAZUS performs and how it assesses losses, it begins by a definition of the hazard. For instance, with a flood, we need to know what the shape of the land is so that we know where water is coming from and what happens when it arrives in our area. With an earthquake, we need to know what types of soils exist. We need to know various other things in order to best determine how an earthquake is going to impact our region. Once we know about the hazard, we can define and overlay the inventory. In other words, we can figure out how many buildings are located in our area, how many people live there, and where those buildings and people are located, so that we know how that information, how that exposure will interact with the hazard itself. With that information, then we're then able to determine how much damage will actually be incurred from the disaster. And don't forget, we also can determine where that damage is going to take place and what it's going to cost. That leads us to the final step in the loss estimation methodology, which is the estimation of those losses. And HAZUS will provide us that information, as you will see in this session, not only as tables, but also maps and various other forms of information. HAZUS functions, as we said earlier, based upon scientifically defensible approaches. It does this with the use of damage and loss functions. Those functions allow us to determine what's going to happen if a disaster takes place based upon the type of exposure we have in our area. An example of functions that calculate losses and damage would be found in the hurricane model. Consider that that model looks at 1,884 unique types of buildings, and for each category of building, there are 45 damage and loss functions, and that brings us to a total of approximately 85,000 unique damage and loss curves for that model. Needless to say, this is a scientific approach, and it looks at what is going on in an area, the hazard that is impacting that area, and what's going to happen as a result of that hazard. Once HAZUS has calculated its losses, it provides a wide range of output, literally hundreds of pieces of information that are accessible to you as a HAZUS user. This table shows us examples of that output. If you look where you see a check mark or an X, you'll find that these are things that HAZUS provides for each hazard. You can break this output into 4 categories. We have direct damages, which address things like our facility locations, the high potential loss facilities like nuclear plants and dams and so forth, transportation systems, utilities, and other things. We have induced damages, which look at issues like fires that might follow from an earthquake event, release of hazardous materials, and, very importantly, debris. And we have direct losses, which include things like how much it will cost us to repair facilities, what losses might be from income, casualty law estimates that might occur from a hazard, and the importance and location and determination of shelter needs. Finally, we look at indirect losses, which include things like shortage of supplies, sales declines, costs from long-term and short-term economic impacts, and again, a variety of other things. You'll note that the earthquake model currently provides practically everything on this list. The flood model provides the vast majority of items listed on this, and the hurricane model provides a great deal at this point, but it is still under development, and in addition to the things listed here, other parts of this table will soon be checked as that model matures. Well, why don't we go ahead and take a look at an actual HAZUS model and the kind of things that you can actually do with this software. What you're looking at is, in fact, ArcMap, one of the important applications that comes with ArcGIS. For those of you that are ArcMap users, you'll probably recognize this screen as looking very, very familiar, with one fundamental difference, and that is the addition of the 4 menus that you see here: Inventory, Hazard, Analysis, and Results. We'll go ahead and look at some things that we find under that Inventory menu first. If we click on the Inventory menu, we'll see a list of options drop down that allow us to find out what kind of exposure we have within our area. Among other things, we have what we term general building stock, and that is information about structures that are found in our community based upon aggregate totals to what we call census tracts. On the map that you see on the screen over here on the side, the areas that are shaded in the colors here are actual census tracts. These are areas which have typically between 3,500 and 4,500 people in them. Well, we can actually click on the general building stock option and go over here to the, for example, dollar exposure table, and HAZUS will open a window for us that tells us what we know about how much dollar value we look at within this particular area. You'll notice that there's a tremendous amount of information available from this window. Let's go ahead and take a look at some of the things we find here. Under our Building tab, we find, for instance, information about what we call general occupancies. There are 7 of those considered in HAZUS. If we look at the column headers, we can determine what those mean. Residential structures, commercial structures, industrial, agriculture, and by scrolling over, we would see educational structures and some other ones. We also can look at specific occupancies, which include a breakdown of each one of those general occupancies. So we have, for instance, single-family housing, multifamily housing, and a variety of other types of categories. In addition to information about building replacement costs, we have information about contents, and again the same types of tables with specific and general occupancies, and we can look at a total accumulated dollar exposure as well. Well, one of the things that makes HAZUS a very user-friendly tool is the ability to quickly generate thematic maps. If we go back to our general occupancy table type, for instance, all that we need to do to graphically display where our dollar exposure is for residential housing or structures is to click on the column labeled RES and simply click the Map button. Once we do that, what HAZUS has done, and we can see this by clicking the OK button, is produced for us a thematic map which shows us where residential housing is and where the greatest dollar values are actually found. Areas on this map that are shown in the darker colors of orange down in these areas indicate where we have a higher exposure of residential housing in terms of its dollar value. Now, in addition to the considerable amount of information that we have about aggregate data, we also have a great deal of information that HAZUS provides right out of the box and that can be enhanced that's based on site-specific locations. An example of such data includes what we term essential facilities. We'll click on that option, and you'll note that we have 5 major categories of essential facilities. Medical care facilities include things like hospitals and healthcare clinics. Fire stations we'll find as well. We'll find police stations, various emergency response centers, and schools. These are all facilities that are considered critical to the ongoing functioning of a community after a disaster has taken place. Well, one of the things that's really nice about HAZUS is that, again, it is user-friendly in that we can click simply on one of the tabs and tell the software that we want to map the location, in this case of medical care facilities, only by clicking that map button. And HAZUS will, as we'll see when we click our OK button, generate a map that shows us where those hospitals are located and even using an appropriate symbol. Let's go ahead and go back to the inventory menu and just talk about a few other things here. We have lots of other site-specific information. Here you see high potential loss facilities. Again, those are the locations of individual dams and various other types of high potential loss value facilities. You'll also see a very important column called, or option called UserDefined Facilities. We can actually use that to enter individual structures that we might be interested in modeling in our community. That means that even if HAZUS does not provide that information, you as a user of HAZUS can enhance the power of this tool by adding your own data. We also have transportation systems, things like bridges and roadways and various related types of data, utility systems, and we'll look at many things there. For instance, different types of water, potable versus waste, oil, natural gas, electric facilities, and as was the case in the other tables we've looked at already, we can break that information down even more finely, in this case, facilities and pipelines. We'll go ahead and click the OK button to close that window. There's a great deal of information, again, found under that inventory menu. If we also have hazardous materials, demographic data about how many people live in that area, when buildings were constructed, and just a variety of other very important types of information. Now, one of the great advantages of having HAZUS designed on a GIS platform, such as ArcGIS in this case, is that not only can we take advantage of the powerful amount of information that this tool comes with right out of the box, but we can quite easily add additional information to our maps as well to provide a context for what it is that we're studying. For example, in this case, I'm simply going to go to the View menu and go to a bookmark, which is just a preset map that I've designed. We'll come down here to specifically a smaller area of that larger geography in southern Alabama, and we'll go ahead and very easily add streams to the map. Let's go ahead and turn off these other layers so that you can see that. We can add streams, we can add roads, we can add railroads, and we can add a great deal more. We can even add photography to this map. I'll take advantage real quickly here of a tool that comes with ArcGIS, again, right out of the box, called our magnifier, and we can add free photography to very quickly see what is actually located in that area. Now imagine yourself as a HAZUS user determining where damages are expected to occur and then being able to integrate other information such as photography so that you can better understand and explain what the impacts are of those hazards on your community. Let's go ahead and close this window and we'll come back and take a look at some other information here. Clean this up just a bit and go return out to our full window once again. Now, there are some other things that we'll find in HAZUS in addition to all that inventory information. Our second menu is the hazard menu. This is a wonderful resource that allows us to model various types of disasters that we believe might occur in our community, and then we can see what the impacts of those disasters might be. We'll come to this hazard menu in this example and we'll choose Scenario, and it opens up a nice wizard for us, easy to use. We'll click the Next button and we'll take a look at an example of a historic hurricane. We'll click on Historic and choose the Next button, and this will then elicit a list of all the hurricanes that are Category 3 or higher that have occurred between 1900 and 2001. Again, this information is right out of the box with HAZUS. We've not provided it with anything at this point. Everything is right with the tool set. Now we can even click on the Region Filter button, and that will filter out for us any storms that have not had some impact on the area that we're studying, and we call that area our study region. We can go ahead and click on one of these storms. We'll choose Hurricane Opal as an example in 1995, and we'll click the Next button. What that will then do is produce for us a map which shows us where Hurricane Opal passed through, and that's indicated by this black line on the map, as well as information about how strong the winds were from that particular storm. Now remember, we can now take that information and we can assess what might happen to our community based upon what kinds of structures and what kind of population are located in that area, and what might then occur today were that same storm to happen. We click the Next button, and it gives us a description of that scenario. Click Next again, and in this case we'll say no because we've already loaded a scenario that we're going to look at in just a few minutes. So we'll choose Next and finally finish the wizard. Now another thing that we can do as users of HAZUS is we can come to our Analysis menu and we can actually understand exactly how it is calculating damages. If we come to Analysis and we go to Building Damage Functions, for instance, HAZUS will produce for us a window. We'll resize that so you can see it better. It'll produce for us a window which will show where damage occurs under certain conditions. For instance, we can look at a type of building such as a wood structure, and we can open up our menu options here and we find out that we can look at different types of wood structures based on whether they're single-family homes and how many stories, whether they're marginally engineered multifamily units, and just a variety of other things. If we click on a single-family home as an option, HAZUS in this right panel will produce for us the function damage curve or damage function curve, which tells us with the different curves how strong wind has to be, which is shown here on the bottom axis, for certain types of destruction to occur, which give us a probability of destruction on the y-axis. And you can see that the minor destruction occurs with smaller amounts of wind or lesser amounts of wind, and major destruction has to require higher amounts of wind. Intuitive, but again, scientifically based information. Now you remember I did say that the hurricane model, which is what we're looking at now, has thousands of damage functions. It doesn't look like that might be the case here on this window, but you can start seeing how that might be possible when we go over here and change, for instance, the type of roof that we're dealing with. Again, note the damage functions change here now. Whether or not there's secondary water resistance present, what type of roof deck attachment we might be looking at, and just many, many other things. And again, this is what makes HAZUS so powerful, because it's user-friendly and it's scientifically assessing those damages. Let's go ahead and close this damage function viewer and take a very brief look at our results menu. Under the results menu, we're able to determine what we expect might happen to our community if the type of disaster that we're describing to the model were to take place. Now, in the next section, we're going to look specifically at output from a major hurricane model that might take place within this area, and we'll explore this results menu in considerable detail at that time. For now, let's go ahead and switch back over to our presentation and summarize where we're at this point. So far, we've come along and we talked a little bit about what HAZUS is, why HAZUS is important in terms of how much disasters cost our nation every year, what kind of benefits that the tool can provide to us, what it actually can do in terms of hazard support, and how it actually functions in terms of its methodology and loss functions. And then we've started to look at the output, but now we're going to explore that information in considerably more detail. Let's go ahead now and take a detailed look at the hurricane model. The HAZUS hurricane model supports 22 Gulf and East Coast states as well as the state of Hawaii, all shown graphically on this slide. There are many different kinds of scenarios that you as a HAZUS user can run. For instance, you could select to define an individual storm. For instance, you can literally come along and tell the model that you want to predict the loss estimates from a storm that travels a certain distance with a certain type of strength at a certain speed, and the model will predict those losses. As you also saw, the model comes with literally hundreds of storms based upon historical events, and you can then look at what might happen to your community were one of those historical storms to occur at this present time based upon what type of exposure your community has to hazards. In addition to modeling individual storms, we can also do what is termed a probabilistic analysis. This looks at the statistical likelihood of a hurricane of a specific size occurring within the area that you've defined, and it then looks, of course, at what kind of losses that you might expect from that type of an event. Now let's go ahead and take a look at a specific example. In this case, we're going to examine what might happen if we were to have a major hurricane along our U.S. Gulf Coast. And again, we'll return back to the same model we looked at previously. We'll click again on the HAZUS window, and let's see what we can find out. First of all, what we can do with this tool is we can come under our results menu and we can actually map the wind speeds. So we'll go to wind speeds, and we're allowed to view a table which shows us how strong that wind was at its maximum in terms of the peak gusts, as well as the maximum sustained miles per hour that that wind actually was having within each area. That information is reported on the basis of census tracts, which again are areas that you see on our map over here that have around 3,500 to 4,500 people in them. Well, we can again click on any one of the columns in the table, and simply by clicking the map button, we can graphically see where the winds might have been strong. We'll close this window. Here, what you see is displayed a line which represents where our storm might have occurred, as well as the peak wind gusts that might have been associated with that particular storm event. And we'll go ahead and move over to some more results. Let's go to our results menu, and let's take a look at what we might expect to happen to our building stock were we to have this kind of an event. We'll go down to General Building Stock, and we'll take a look specifically at building stock by occupancies. Now, you might recall from earlier, what that refers to is what kind of use buildings are actually placed for. This includes the things listed here on the slide: residential, commercial, industrial, agricultural, religion, government, and education. What we can now do is we can select one of these things. Let's take a look at residential, and we can look at a probabilistic estimate of whether or not we expect certain types of damage. Here we see minor damage, at least minor, moderate, and we can go across this table to look all the way to the likelihood of destruction of residential structures in each one of these census tracts. We'll go ahead and click on a severe column here to see which areas we can expect severe destruction for residential buildings. We'll click the map button, and again, HAZUS will generate for us a thematic map. We'll close this window. And what you can now see is a map where we see areas highlighted in orange here. Those are areas where we expect the highest amounts of destruction, and where we see the lighter colors, those are areas where we expect less destruction. Not surprisingly, the greatest amount of destruction from wind-related hurricane events of this type would be found along the coast, where those winds will be initially the strongest and then decreasing inland as the hurricane travels farther away from the water. Now we can also see the wind speeds associated with those different census tracts because we mapped that earlier, but nothing prohibits us from unchecking that information, since this is, after all, a GIS, and that means we can look simply at where we expect the severe residential destruction. Remember, this is a geographic information system, so we can quickly display different types of information, and we can see how that information relates just by the click of a button. Let's look at some other results. Let's go to our results menu once again, and we'll come down this time to one of our site-specific tables. We'll choose Essential Facilities. Let's take a look at where we expect schools to sustain negative impacts from this hurricane. We'll click on the Schools tab. What we'll find is a great deal of information, but unlike what we looked at with general building stock, this again is reported by individual schools. So we can actually look at individual school buildings, and we're able to determine how many days those buildings are likely to be unavailable and the probabilities, again, of different amounts of damage occurring in relation to those facilities. Let's go ahead and click on our severe column to find out which schools are expected to possibly be severely damaged. We can click on the map button, and again, HAZUS generates a useful map for us. We'll uncheck our severe for residential, and we can quickly see by looking at the darker colored symbols on the map which schools are likely to sustain the greatest amounts of damage. This information is extraordinarily helpful then for that mitigation planner that wants to go out and determine where they need to look at different types of buildings because of more risk that might be present in some areas versus others. We'll go ahead and uncheck this layer so we can look at some more information. Another thing that we find that's very helpful in HAZUS is that it gives us estimations of debris. If we go to our results option, we can come down to the debris table, and we'll notice that not only do we get estimates of debris, but it's broken down by different types of material. Here we see a distinction between brick and wood related debris and concrete and steel debris. This is an indication of what kinds of equipment is going to be required to actually remove that debris after the disaster has occurred. And we can actually determine where that debris is located again by clicking the map button to see where we expect those problems to take place. We can also look in the hurricane model at tree debris related material, and we can map that information as well. Let's look at one final table, and then we'll explore a few of the reports. Let's click on our results menu once again, and in this case we'll come down to the shelter option. What you'll find in the shelter tables for all of the models, hurricane, flood, and earthquake, is a distinction between households that are displaced, which are people that are going to have to leave the area based upon damage to their homes, versus people that might require short-term shelter. And that distinction is determined based upon the income of the population in the individual areas of your community, whether they have home ownership, the age of the people living there, and a variety of other things. You as the user can come in and actually modify the parameters used to determine shelter needs, and HAZUS will then reassess losses if you have done so. We'll go ahead and click the close button. Let's take a look at a few of the reports that we might see as a result of this event. We'll come to our results option, and we'll walk down to summary reports. And what we are shown now is a window which lists the many different reports that HAZUS will provide to you, again, right out of the box. Here we find a list of reports related to our inventory. In other words, what is at risk in our region. We find a tab labeled Buildings, where we're able to see how much damage to different types of buildings can we expect from the event that we're studying. We find induced losses, which in the hurricane example include only debris, and we'll find direct losses, which for hurricane includes economic losses for our buildings and our shelter requirements, and then we'll also find some miscellaneous reports, which include two important reports which are often used by HAZUS users. One is the Quick Assessment Report, and we'll view that simply by clicking the View button, and HAZUS will then generate the report by going to the actual data that you provided for your region, again, either out of the box or information that you have provided. And with this quick assessment report, we're able to, as the name implies, quickly get some information about our region. Here we find regional statistics. For example, the number of buildings that are located in the region, number of people living in the region that we see here, and the dollar exposure for both residential structures and all structures combined. We are also able to come down and see what might happen from our specific scenario results. So we can see that the maximum peak gust wind speed is 159 miles per hour in this model, and the amount of damage to different types of buildings at different damage levels, here minor, moderate, severe, and so forth, is what is shown on here. Again, remember these numbers are only approximations, and the quality of the data that you supplied to the model will help drive those numbers to a more realistic estimate, but they are exceptionally useful from a planning perspective, since it allows us to better understand where we are at risk within our communities. We will also find other information on this and other reports, things like shelter estimates and economic losses. Let's take a look at one of the more detailed reports now. We'll close this window, again return to our summary reports window, and we can come down to our buildings tab. In this case, let's look at our damage by building count by building type. And we'll click on our View button. What we're able to now find is a breakdown. Go ahead and resize this window so we can all see. We'll find a breakdown by county within our state that we're interested in, by type of construction material listed here on the side, and again, by the amount of damage, none, minor, moderate, severe, and so forth, giving us a rough estimate or an estimate of the number of buildings that we can expect to sustain damage from this particular type of event. Again, lots and lots of wonderful information that we're able to then use to better plan for and prepare for disasters of the type that we might be studying in this scenario. We'll go ahead and close this window, and let's look at one of the really useful reports. We'll go over here to our Other Reports tab again and click on Global Summary Report. This is a report, as we open it up with the View button. This is a report that will give us kind of the big picture of what we expect to take place within our particular study area. So we'll go ahead and we'll scroll through. We'll start out by looking at a table of contents about what's actually found in the report, and we'll continue with what is a description of the area that we're looking at. Here we're exploring a region which has approximately 21,000 square miles and about 379 census tracts with approximately 540,000 households and a population of about 1.4 million people. Again, remember, this information comes right out of the box as soon as you install HAZUS. So it's valuable for its information resources even before you do analysis with the model. We'll go ahead and continue through the report, and we find we have an estimate of approximately 500,000 buildings which have a value of approximately $68 billion, and then you find a breakdown of different classifications of buildings and how much value that those buildings actually have. Here we find that, for instance, residential structures occupy the vast majority of our exposure within this particular region. We'll go ahead and now continue through the different scenario, or the scenario we've defined, and what we're able to do is look at the specific parameters that have been entered for this hurricane event. We were able to see that we entered 3 specific points in time, and the amount of time between each point, because that tells us how fast that storm has traveled, and the winds at each point in time, and the associated pressure and so forth. With that information, HAZUS is then able to calculate our losses. We can now see those losses by moving through some of the rest of the report. For instance, we're looking at around 170,000 buildings with moderate damage, which is a significant percentage of the buildings in the region. And approximately 50,000 of those buildings might be completely destroyed. If you want more information, you can then scroll down and look at a breakdown of damage by the amount of damage, by the amount of structures, and by the different occupancies, again, that HAZUS supports. Remember, again, this is a general report. You can get much more detail by going to the individual tables if you so desire. We can even scroll down and look at different types of buildings by construction materials. We can move to some of the other pages and look at our essential facilities damages. So a breakdown of how many structures are likely to be moderately damaged versus totally damaged, and how many structures will be expected to have certain losses of use. We can continue moving through and find estimations of debris. This is often something that a planner needs to consider. In this case, for this particular event, again, just for this study region in southern Alabama, where the storm that we've looked at to occur, we'd be looking at as much as 70 million tons of debris, requiring over 100,000 truckloads if we chose to remove that debris from its location. We have an estimation of shelter requirements with 123,000 households likely to be displaced. And as we all know from recent events, those kinds of numbers are fairly realistic. If we continue to move through the report, we look at building-related losses, and it gives us an estimation of how much we can expect in losses. And it breaks information on our economic losses down by property damage for different types of categories, as well as business-related interruption losses. And again, we can continue through these reports and find more and more information that allows us as planners and responders to prepare for events of this type. Let's go ahead and close this window and our report window, and we'll move on now to our next hazard. Well, the next hazard we're going to explore is the flood model. When you look at what HAZUS can do in terms of flood modeling, it actually provides a wide range of capabilities. An example is the ability to study what we term specific return intervals. An example of a return interval might be a 100-year return interval, where we are looking at an event that has a 1% chance of being equaled or exceeded in any given year. We can also look at a specific discharge frequency. That literally means that you can enter into the model for individual streams the amount of water that is flowing through those streams, and you can assess where that water will go and what's likely to happen to our exposed inventory, again, those buildings and the population where the flooding takes place. Such information as discharges can even be attained from the internet using either historic information or, in some cases, near real-time data. You can also, with the flood model, examine annualized losses. This is a situation where, as a planner, I need to determine what I can expect happening to my community in terms of losses from flooding on an annual basis, so that, again, I can more effectively plan for responses to flooding-related events. The HAZUS flood model also provides a tool called the Quick Look tool, which allows us to actually say to the model that we believe that water is located in a specific area and that it is a specific depth, and then allows us to look at what we might have happen to our general building stock as a result of that water being where we say it is. One of the really powerful capabilities of the flood model and the other HAZUS models is the ability to provide what we call what-if scenarios. This is where we not only can look at what might happen to our community based upon what exists at that time in reality, but also is to come along and say, what if, for example, we were to build a levee in our community? What might be the differences in losses from flooding-related events? We can look at What happens if we have a dam installed in the community? What happens if we have other type of flow regulation devices? What might be the impact of velocity from floodwaters in our community? We can look at other types of what if scenarios, such as what if we were to implement a buyout program in a flood-prone area? What might we be looking at from a reduction in losses perspective? So many different uses of the flood model exist. And what we'll do now is actually explore one such application. In this case, we'll take a look at a scenario which involves a county in southern Indiana named Orange County, and we'll look specifically at what might happen based upon 100-year flood return events. We'll click back again on our HAZUS window, and in this case, we're going to go to our HAZUS startup screen, which we can quickly do by clicking the button up here in the upper left corner of the screen, and indicate that we want to open a different study area, our study region, and we can walk through that wizard very easily and select our model that we want to explore, tell the application that we want to look at the flood-related implications of that model, and then we'll click the Finish button and wait just a moment for HAZUS to open up that flood-related information. Now, as this application opens to look at the flood model, I'll point out several things that are very useful. What you're looking at here in the background is information about the elevation of the terrain and the shape of the terrain in the area that we believe is prone to flooding. What's just appeared on the screen in the orange is areas where we believe would actually be flooded based upon a 100-year return period event. Now what we can do is we can look at what the results would be to that community if this flooding were to occur as predicted. We can do so again by coming to our results menu and telling the application that we want to view this study case, or the area that we're looking at in our model, based upon the 100-year flood. When we say OK, under our results menu now, we see lots and lots of information opened up and available to us. Let's look at just a few examples of what this flood model has predicted. As an example, we'll come down to our general building stock. Remember, that's information aggregated to a geographic area rather than being specific points. And in this case, that area in our flood model is the level of a census block, which is a much smaller area than a census tract based upon physical features such as rivers, roads, and various other things. Also, we find in this flood model that we can look not only at a full replacement cost, in other words, how much will it cost us to rebuild those structures in that area, but we can also look at the depreciated replacement cost. And that is really important to us as planners because we need to be able to understand what we can expect to have come back to us from insurance versus what is going to be required in order to rebuild in the areas that have been damaged by flooding. If we click on the Buy Full Replacement option, we can see again the range of information that HAZUS provides, once again organized into an easily navigable format. And if we click again on our General Occupancy tab, we're able to easily see that we have those major occupancy categories as we did in the hurricane model. We're also able to look at what we term pre versus post firm information, and this reflects whether or not in this community we have enacted flood programs that require certain building practices to take place when structures are constructed. For example, we may require in our communities that we need to have first floors built at a certain height if they're in flood-prone areas. Within this model, you can indicate which areas do have flood regulations in place and which don't, and those tell you which are pre-firm or pre-regulation and which are post-firm or post-regulation. And you can also look at total losses as well, regardless of whether it's within a regulated area or not. As we also could in the hurricane model, we can look at the general occupancy information, but we can also look at specific occupancies, again breaking information down by what type of residential structure, what type of commercial structure, and so forth. And we can look at information by building type. And again, that breaks things down into how a building is constructed based upon its construction material. And we can look at total information as well, which includes a summarization of all types of buildings and what we're looking at as a result. As we could with the hurricane model, in most all tables, we can click on a column such as total estimated losses. These are reported in thousands of dollars as shown up here on our title header. And if we click on our map button, what we're able to see again is a map that HAZUS will produce for us that shows us where we are likely to be most susceptible from an economic loss perspective based upon what kinds of inventory is located in different areas and based upon the amount of water that is expected to be found from this type of flooding event. On this map where you see the darker colored areas, those are indications, of course, that we expect more damage to occur from an economic perspective from flooding of this type. Now, as we could with the hurricane model, not only can we look at aggregated information such as what we've just explored, but again, we can also look at damage to individual buildings. So let's go ahead and turn off the layer that we just displayed, and we'll come here under the results menu and scroll down to Essential Facilities, and what we find now is that in fact the model predicts that there is going to be a medical care facility located in the flooded area. We can find out exactly where that facility is by clicking our map button, and once again HAZUS will generate for us a map that shows us where that facility is located. Here's that single dot indicating where that facility is. And now remember, again, because we have those powerful GIS tools, we can even gain more information and understanding about this by, in this case, zooming in on the map. We'll click our magnifying glass and we will focus in on the specific area where that facility is found. Now what we can see is that that facility is in the flooded area as indicated by HAZUS, but that doesn't necessarily tell us everything that we want to know, because perhaps we want to know just how much water is predicted to be found in that area, and we can easily do that with our GIS tools, such as our identity tool. We can click on this button and tell the application that we want to look at the depth of water in our flood depth grid, and you'll note now by clicking at different locations in that grid that where it says pixel value, this tells us the number of feet of water in the location that we clicked. And as you can see, when we click in different areas of that grid, the depth of that water will change. Now this is really important to recognize as a key attribute of how HAZUS works, because unlike some methodologies where you would say this is an area that is flooded and we don't know exactly how deep the water is, but we're going to assume certain amounts of damage, what HAZUS does is it again takes that scientific approach and says, tell me exactly how much water is found throughout the area that's flooded, and I will then tell you as a tool what amounts of damage that you can expect based upon that information. Again, using those powerful damage curves that the model actually comes with. We'll go ahead and click on our close button to remove that from our screen, and we'll return to our previous view and do a little more exploration of the flood model. In addition to looking at individual facilities, as we just did, again, we have a great deal of information that is available to us as planners, such as estimations of how much debris we can expect, estimations of what our shelter requirements might be, and a variety of other things such as economic impacts. Let's take a quick look again at our shelter needs, and we'll click on our shelter option, and as we did in the hurricane model, we note that we do have an indication not only of displaced population, but also an indication of how many people need shelter, are expected to need shelter within each census block. So we can map those short-term shelter needs if we need to. And once again, HAZUS will produce a map where we'll see where we expect shelter demands to be higher, and with this information, before that flooding occurs, we can try to ensure that we have those resources in place that might help us address those shelter requirements if and when they ever need to be addressed. As we did in the hurricane model, we can also come to our results menu and we can see a wide range of reports. Let's go ahead and come down to our summary reports tab. and go to the Other tab, and here we will find a quick assessment report just as we did for our hurricane model. We'll click on the View button, and again the model will generate a report giving us a quick overview of what we can expect in terms of losses from this type of flooding activity or event. Again, we start out with an overview of what our region, our study area looks like. How big is it? About 400 square miles in this case. How many buildings are located in this area? How many people are found in the area? And what kind of exposed value do we have in terms of economic risk to our buildings in the area of concern? We can also, with again the quick assessment report, determine our displaced population and short-term shelter, as well as a breakdown in a general sense of economic losses, so that we can again determine what this fairly likely flood-related event might cost our community if it were to take place. We'll go ahead and close this window and take a look at just a few more reports. We'll come to the Results menu once again, come down to Summary Reports, and in this case we'll click on our Buildings tab, and let's examine in this situation the building damages by the different types of occupancies. We'll click on Building Damage by General Occupancy, and we can click our View button, and once again HAZUS will generate that report for us. In this case, since we've asked for more detailed information, HAZUS will indeed provide exactly what we've requested. Let's go ahead and expand that just a bit more for you. Okay, and here we have the breakdown of different types of uses for buildings in the area and the number of square feet and thousands of square feet based upon the percentage of damage that we can expect based upon what the model has predicted if we were to have a flood event of the type that we're exploring. Let's take a brief look at economic impacts as well. We'll come down to the Results menu, come down to Summary Reports, and take a look at our Losses tab. Here we find a wide range of economic impacts. Something that is particularly useful to point out is, again, we can look at a general overview here of damage to buildings, but also we can look at damages to other critical parts of our community, such as transportation facilities and utilities. And we can do that again either in these reports, or we can look specifically at the details provided in the tables. We'll come and take a look at direct economic losses for buildings as an example. And again, HAZUS will generate that report for us. And we will go ahead and resize it a bit so that you can get a good look at it. As we scroll down here on our window, you'll note that a breakdown of economic losses has been provided not only for capital stock losses, which include things like structural losses, contents, and inventory, things again that can be sold in a building, as well as, though, information related to income losses. So what are the costs, for instance, to relocate structures? What are capital-related losses? What are wage-related losses? And even what are rental income-related losses? And again, remember, all of this information has been calculated based on the parameters that you entered, based on the inventory that HAZUS has provided or that you have enhanced, as we'll discuss in a few moments or a few minutes, and provided a scientifically based estimation of these losses. We'll go ahead and close this window and look at one remaining report. Again, once we'll come to our Results menu and go to Summary Reports. And I want to point out that in the flood model in particular, we can not only look at the things that we've described, but we can even look at information such as the losses to vehicles. What you'll find is that HAZUS not only assesses total vehicle losses, but it also looks at losses from a day versus a night perspective, because the model inventory comes with information that indicates where we believe those vehicles will be at specific times of the day. We'll click on Direct Economic Losses for Vehicles for the daytime, and we'll view that report. We'll scroll down and once more resize so that we can all see. And when we look at the report, it's useful to point out that not only does it give you an estimate of vehicle losses, but it looks at the type of vehicle. So we break information down by cars, light trucks, and heavy trucks. This information is taking into account how deep water actually has to be within the area that flooding is occurring in order for those vehicles to start sustaining damage. Well, we'll go ahead and close this window. And before we actually leave our HAZUS flood model exploration, I think it's also important to note that HAZUS for our flood model really is not intended to replace the regulatory flood maps or studies that might be done for a community, and it is not used to set insurance rates for flood-related events, but it has extraordinary potential and potential implications as a planning tool for flood-related hazards in your community. Let's go ahead and now look to our last example of a hazard. And in this case, that will be an earthquake-related hazard. HAZUS has the ability to look at many different types of scenarios related to earthquakes, as it did for both hurricane events and flood events. Examples include user-defined events. For instance, we could come in as a user of the tool and literally say, we believe that an earthquake is going to take place at a specific location, at a specific depth, and be of a specific size or magnitude, and now we want to see what will happen to our community as a result of inputting those parameters. In addition, we're able to explore a database that comes with the tool set that literally provides thousands of historic earthquake locations so that we can then ask the tool set to ascertain what kinds of damages we might expect to see if an event that has happened in the past were to once again occur today or in the future. We can also, as we did in the hurricane model, look at what is termed a probabilistic event. And this again is an example where we are looking at the statistical likelihood of an earthquake of a certain size occurring within our area and allowing us to determine what kinds of losses we might receive as a result of such an earthquake event. Now, as we did for our other models, we'll take a look at a specific example of an earthquake. In this situation, we're going to look at a very earthquake-prone area, which is Charleston, South Carolina, an area that has received large earthquakes in the past and that may very well receive them in the future. And we'll see what might happen based upon the exposed inventory in Charleston today if we were to have an earthquake occur in that location. Let's go ahead and again return to HAZUS and move to our HAZUS wizard and tell it that we want to open up an earthquake example. And we'll click our Finish button, and in just a moment we'll see HAZUS regenerate, showing us the area around Charleston, South Carolina. Now, as we had in the previous examples, I've already run an analysis, and we're going to sit for a few minutes and take a look at the loss estimations that might occur if we were to see an earthquake of the size that we've described. We'll come under our Results menu first, and actually before we do that, why don't we go to the Hazard menu and come down to Show Current. And it's useful to note that we can actually see where the earthquake is. So we'll click the Map button, and that will then display a layer, a hazard scenario layer. That's our earthquake location. And if you look on the map, this is where that earthquake would be centered from. We'll come here now to our Results menu, and we'll start taking a look at some of those loss estimations. We can move down to, again, our general building stock, and once again, that's the aggregated data in this case to the level of a census tract, as we did in the hurricane model. And we can look at specific estimations of where we expect losses to occur. So, for instance, we'll come over here and we'll take a look at general building stock by count of structures. And we'll allow the table to open up and tell the application that we want to look at a specific category of structures, in this case, those being of a low design level and with a building quality built to code. If we look up here under building type, you'll see a wide range of structure types, ranging from wood structures to steel to concrete and a whole variety of other types of structures. Notice that there are many more breakdowns of building types found in the earthquake model than we did find in the other models, specifically the flood model as an example. This reflects the fact that HAZUS, again from that scientific approach, takes into account that we need more information about things like building construction quality and standards and so forth for some types of hazards than we might need for others. And in this situation, we'll look at a wood structure. Again, we'll return to our window, and we're able to now see a count of the number of buildings that we expect to receive damage. Well, as we saw in our previous models, this damage is broken down based upon how strong the earthquake is expected to be across the region and the degree of damage that's expected to occur throughout that region. So as a case in point, let's look at where we would expect moderate amounts of damage to occur and the number of structures listed here in this column that we expect to receive at least moderate damage. And we'll click our map button. And once again, HAZUS will generate a layer of information for us. We have a legend over here on the side that indicates the number of structures within each of the areas that are colored, those census tracts, that we expect to be moderately damaged. And we're able to see on the map, in our thematic map, where those damage areas are expected to be. So in this case, if we look at the red colored areas, those are areas we expect to receive the most damage. The orange colored areas, the next most significant damage, and so forth, in terms of the number of buildings that we expect to be at least moderately damaged in this particular example. Well, as we could in both the flood and the hurricane model, not only can we look at aggregate loss estimates, such as what we just explored, but we can come and look at individual structures. We'll do that by moving to our results. And in this case, let's take a look at schools that are extensively damaged. If you recall, schools are found under our Essential Facilities table, so we'll open that table. And note, again, we have the different tabs indicating different types of essential facilities. We'll click on the Schools tab, and here we see a list of the schools in our community, again, individual buildings, and we can scroll across the table and look at the probabilities of different amounts of damage for each one of those school structures. So if we, for example, click on where we expect to see extensive damage, we see probabilities of that type of damage listed for each school. And as we can for many types of HAZUS information, we click on the map button, and the application will generate a map for us that shows us which schools that we expect to see the most damage. Now, don't forget, HAZUS is looking at the environment in which these schools are located, so it's taking into account information about how much energy is released from the earthquake, what kinds of physical conditions exist, such as soils and many other types of things that we can either use, again, out of the box with the tool, or that we can enhance with locally available information. Many, many other things exist out of our earthquake model for our results. If we come to, again, our results column, we can scroll down and look at, as an example, our utility systems output, and we'll see, just as an indicator of how much detail is really provided in this tool, we can look at our potable water facilities, wastewater facilities, oil systems, natural gas, electric power, and much, much, much more. So let's say we want to explore damages to electrical facilities. We can click on one of those columns and again simply map that to see where that damage is expected to occur, at which facilities. That information then gives us the ability to place resources in the field to address where that risk might take place, either after, during, or before that particular event happens. We'll close this window and again look at one other type of very important table. If we go to results, we can look at our debris table, and as we saw in some of the other models, we see that the HAZUS earthquake model breaks debris down not only as our total debris estimation, but based upon how much effort will be required to move that debris from its location to another place where we can actually store it or do something else. If we click our close button, we can close that table out. And let's take a look at some of the reports out of the the earthquake model. We'll come to our results menu. And as we saw with the other two models, we can click on Summary Reports and scroll through a whole list of tabs that provide us, again, a wide range of information that summarizes what we expect to see in terms of losses as well as our exposure in the area. We'll click on our Inventory tab. This gives us a description of what is at risk within this area. Our Buildings tab describes for us what types of losses and damage we expect. Our Lifelines tab tells us information about how much damage we will see to various lifelines, again, those listed here, their functionality, in other words, are they available after this earthquake, and information about performance of specifically potable water and electrical system components. We can also look at induced losses, again with the earthquake, look at fire estimation, how many ignitions are we expecting to see and where would those be located, and we can get estimates of debris. We can look at details about losses. In this case, we're looking at the time of day and an estimate of casualties. We're looking at economic impacts, and we can look at other types of information, such as our quick assessment reports, again, based upon the time of day that that earthquake event might take place, as well as some other reports that we see. In addition, you'll note a tab on this screen called our third-party tab that reflects that HAZUS does have the capability to integrate information from some third-party tools, such as those listed in this particular case. Let's look at a few of these reports in particular. We'll click on our Other tab, and let's look at one of our quick assessment reports. If we click on our 2 a.m. quick assessment, in other words, the middle of the night, when people are expected to be located in the residentially dominated areas, we'll click our View button and see what might happen under those conditions. And HAZUS will produce for us a report that says we expect this range of losses for our economic impacts. We scroll down and find that we get an estimate of building damage in terms of the number of buildings damaged and the degree of damage. We also get information about casualty estimates, and it's useful to point out that for our casualty estimates, the earthquake model specifically looks at the type of casualty from a level 1 severity level, which essentially is a condition requiring aid but no hospitalization, through life-threatening injuries and even fatalities. And as do the other models, we get estimates of shelter requirements, how many households are displaced, as well as how much public shelter are we going to need to provide based upon this kind of an event. We'll close this report, explore a couple of other reports. Click once again on our Buildings tab. Let's take a look at an estimate of how many buildings we expect to be damaged by general occupancy. We'll click on the View button in order to derive that information. And the application will tell us, we'll expand this so we can all see again. The application will tell us, breaking down the number of buildings by category of use, again by degree of damage, throughout the area that we're exploring. Go ahead and close this window. Look at a couple of other reports. Note that we also have reports about site-specific locations, so we can look, for instance, at hospital functionality. We'll click our View button, and HAZUS will open a report for us. Expand that so we can see. Note that in this case, where we're looking at hospitals, it looks not only at the total accumulated hospital functionality estimates, but it breaks hospitals down into categories based on their size, listed over here on the side, and how many beds are available in those facilities, which is information that comes directly from the inventory that HAZUS comes with or that you have enhanced. It also looks at the amount of functionality estimated based upon how long it's been since that earthquake has occurred. So we can look at what type of functionality for those hospitals we see on the day of the earthquake, 3 days after the earthquake, 7 days after the earthquake, a month after the earthquake, and even 3 months after the earthquake. This information is extremely valuable because this tells us as planners that the hospitals, assuming that our information is correctly input into the model, are going to be of limited use based upon the type of scenario that we've described, and therefore we need to consider how best to address likely hospitalization needs based on what the model has told us and based on our local knowledge of the area. We can go ahead and close this report window again. Let's take a look briefly at our lifelines, and we'll click on the Lifelines tab, and as an example, we'll look at functionality, and in this case, we'll explore highway bridge functionality. Click our View button, and that'll open a table. This will tell us what the number of bridges is available in our region and the percentage of those bridges that are expected to be functional on the day of the earthquake, and again at specific durations of time from the earthquake event. Don't forget, this is a report that summarizes loss or functionality for bridges. Does not prohibit us from going to the table and looking at specific bridges so that we can best assess which bridges are likely to be the most at risk from this type of an event. Let's close this window and look at one final report before we wrap up for the afternoon. We'll click on our Other tab and look at our Global Summary Report. Click our View button, and we'll wait just a moment for the report to generate. Remember, this is pulling from a live database because this is real actual data. Absolutely nothing in HAZUS is canned. It's all pulling from information provided with the model or that you've enhanced. We'll look at this global summary report, again, as it was the case in both the hurricane and flood models. If we click our Next button, we can see our table of contents and begin seeing information about our study area. Here we look at the size of the region, about 940 square miles in this case, the number of buildings that are found in the region, and we discover that 99% of those buildings are associated with residential housing. We continue through a description of our exposure, and we find information about the building inventory, critical facilities, transportation and lifelines. Moving on to the next page, we find details about things like our transportation system in terms of how many bridges do we have, how many segments, how many tunnels, what the replacement value of those facilities is, and much, much more. And we can keep looking at information about detailed aspects of what our at-risk exposure is for utilities and various other things. Finally, we come to the earthquake scenario that we are specifically exploring. So we look at this large earthquake event to see what might happen to our area if it were to occur today. And we start out finding that we might be seeing as many as 80,000 buildings having moderate damage or so, a large percentage of the number of the buildings in the region, and many of those buildings would potentially be damaged beyond repair. HAZUS will then produce for you a table which gives you approximations of the number of buildings damaged based upon the type of use, based upon the amount of damage that might take place. And again, if you wish, you can even look at information by count of buildings and type of damage based upon type of material. We can continue through the global summary and find out more and more information about the earthquake study that we're looking at. So we can look, for instance, at what is our expected impact on essential facilities? How many hospitals might we see damaged? How many would be moderately damaged? How many completely? How many functional on the day of the earthquake? So that this information is very important from a planning perspective, and we can move through and keep looking at more of information of this type: transportation, utility-related information, how many expected facilities we're looking at, how many fires we might see, the amount of debris generated, shelter requirements, casualties, and much, much, much more. And then finally, an estimation again of building-related losses. Now let's take just a moment to explore what you can do now that you have learned a lot about HAZUS and its potential applications. As of 2004, when a utilization report was conducted by FEMA, there were around 4,200 users in the nation, and by 2008, FEMA is expecting over 19,000 users of the HAZUS application. As of 2004, 68% of the states and territories in the country were using this tool for Disaster Mitigation Act of 2000 planning, which is important because that provides access to post-disaster relief dollars that might not otherwise be available. 15% of the participating localities were also using HAZUS in a multi-hazard mitigation planning capacity. We can look at also international applications of HAZUS in Norway, Turkey, Sweden, and a variety of other locations. And we can see that most HAZUS users do fall in local jurisdictions, but also there's heavy use in the private industry, in the academic environment, federal agencies, state, and other organizations as well. HAZUS is a tool that is available to a wide range of users. Those might include people that we term level 1 users, those being individuals that with a minimum of training and access to experts in earth science or building science, those people can come in, install HAZUS, and run effective models in order to determine what might happen to their particular communities. Level 2 users are individuals and organizations that wish to enhance the inventory that comes with HAZUS by integrating information such as local assessors files and other types of data. And level 3 users are individuals which have the ability and the knowledge to move into HAZUS and actually affect how it assesses damages to their environment. In summary, HAZUS has a wide range of applications. It's useful for an emergency preparedness aspect. We can look at developing response plans and conducting exercises. It's extraordinarily useful from a loss reduction perspective, using it for mitigation assessments, deriving whether certain mitigation measures might be effective, and of course using it in a mitigation program capacity. And it has implications in a response and recovery environment as well. Now, the important question that we will leave you with is, where do you go next? One very good resource is found on the website listed on this page at fema.gov/HAZUS. That resource provides information about an overview of the tool, details about the models, a library composed or providing information such as the utilization report that we described, and much, much more. Information about user groups so that you can find out who is using HAZUS in your area and how they are using it, and information about where you can find training on this application. And you'll find that that training resource is part of a large program that FEMA has offered and is offering to users of HAZUS across the nation, which will provide instruction in introductory GIS applications for emergency management, all the way through advanced applications of HAZUS, teaching users and participants how the tool works and how they can best affect changes to that environment that the model operates in. So we've now come to the end of our presentation, and I would encourage you to continue your exploration of HAZUS MH by clicking on the What's Next link that you'll find on the left side of the seminar webpage. The What's Next page is going to offer you an interactive list of the resources that I've mentioned, as well as some others that might be of interest to you. I hope that you have found this presentation to be useful, and that as a result of your participation, you will be encouraged to join the growing community of HAZUS users throughout this country and beyond. We truly value your feedback, and therefore, I would really like to request that you please take a moment to fill out the online evaluation. Thank you for your participation, and goodbye.